As infrastructure manager, SNCF Réseau oversees the maintenance of more than 1,500 tunnels, which the average age is about 130 years. The knowledge of the state of these tunnels is absolutely necessary for the maintenance procedure. With the aim to deal with the structure's evolution, SNCF Réseau can rely on deformations and topography monitoring systems. Over the years, new technologies arise with clear advantages compared to these traditional ways. The OPTIC project was introduced to test new sensors for the monitoring of deformation in order to extend the range of the monitoring methods available for all tunnels. The technology chosen for the experimentation will be exposed to constraints specific to all tunnels, in real conditions to conclude on recommendations for use concerning this type of tunnel. The use cases will mainly be focused on monitoring and works, with for example the monitoring of deformation of damage zone, the railway security mission due to construction close to structures, or the behaviors analysis of reinforcement. According to a state-of-art carried out in 2018, Brie-1 technology was identified as the most promising and relevant technology to experiment concerning the deformation monitoring of all tunnels. This optical fiber technology allows a fixation directly on the tunnel wall or embedded in concrete after a reinforcement work, for example. These fibers are fitted according to a mesh to define function on the information south or the expected movement. Brie-1 technology allows precise measurement of deformations and stresses, and this in distributed manner over its entire length, unlike traditional means of monitoring which measure punctual deformations. This fiber optic technology is already used occasionally in the civil engineering sector, but not yet in the very specific context of all rail tunnels. For the OPTIC project, the experimentation took place in several phases and was the subject of tenders with the company Cementis 1. The first phase took place in June 2020. It consisted of carrying out shotcrete resistance tests on several types of fiber in order to select a fiber reference that could withstand tunnel reinforcement work and its particularly dry spraying concrete. The second phase runs from October 2020 to October 2022. It includes the installation of fiber network in the Encombrous tunnel in the Alps, followed by periodic measurements. Monitoring via topography and crack meters is also carried out in parallel for comparison of the measured values. These 2 years of measurement are interspersed with regeneration work, shotcrete shell, in the instrumented area. The optic fiber network remained in place during this operation. Although the measurement cycles have not yet been completed, this experiment was already confirmed some advantages of Brie-1 technology, but also identified some limitations in all railway tunnels. Implementation recommendation will be published in 2023 to make its use effective and relevant. Furthermore, the automation of acquisitions for real-time monitoring is possible and fits perfectly into the digitalization approach of the civil engineering department. However, the relevance of this automation is to be confronted with the cost aspect, especially because of the high value of the acquisition stations at the moment.